Hello, Tan Binto. We've interacted quite a bit over the years. I have just found an interesting paper at a NICE 2019 conference. Author uses fast retina key points descriptions for images. Fast retina key points. I don't think I've heard of that. Binding of sparse oh, hey, look at that. It's like directly related to HTM. Binding of sparse distributed representations in hierarchical temporal memory. Neomorphic AI Lab, Rochester Institute of Technology. Oh, this is nice. Cool. This is from NICE 2019. I don't know that workshop. It's one of the workshops. Day 3F. So it's one of these workshops. The author was, what was his name? Luke? Let's see if we can find it. No? Or what was it? Bour. B-O-U-D. U-U-D. Okay, so his name's not there. But they might not have it. They probably don't have them all listed out, like the workshops. It's just organizing teams and the main speakers. But so that's cool. Announcement, agenda, tutorials, demos. I'm not paying attention to whether this is an act. Hey, Mark, I bet. Oh, you're not there anymore. Whoever's listening, if you know this, I've got a record. I have a record that has 2 copies of the same basically album. Hey, Mark, you might know this because you're sort of an audiophile and you're of an older generation that would appreciates this form of media. Yes, the king is in. I've got 1 mono and 1 stereo record of the same album. Are those? Because this was recorded in like 50 something, what is it? Well, it says copyright 1972, but I know these recordings came from earlier because they're all pre-recorded. This is like a... Anyway, 1's mono, 1's stereo. Were those actually 2 physically different recordings in the time that they were recording different tracks for mono and stereo? Because I'm sitting here listening to the mono version, trying to compare it to my mental model of the stereo version that I hear all the time. I'm trying to figure out if it's actually different. Anyhow, I'm just curious. Oh, let me look through the presentation. HTM structure, region. Okay, we got to be careful here. We want to say mini column. I think, yeah, let's call these mini columns. We were bad at this in the beginning. We were bad calling this. Oh, the record lathe works. Oh, interesting. Okay, so that's cool. That's the value of having an extra record because it's a totally different recording of the artists. So that's neat. Hello, James. I was just chatting about vinyl records with BitKing and going over our forum, HTM forum. Computers aren't real. Perhaps not. Perhaps what is real? Nothing's real. If you want to learn what we're talking about, it's hierarchical temporal memory. There's a link in chat there. It explains sort of the concept. So they were cut separately as 2 different masters for pressing. They may be the same recording. Oh. I figured that the interesting thing about that for someone nowadays would to have, the only reason you'd want to have 2 recordings, 1 mono and 1 stereo is if they were different recordings. I would hope they were, but I haven't noticed a difference yet in the background. Just stack more layers. I don't think that's maintainable, or I don't think that works the way you think it works. Yeah, when stereo was new, it was a new feature. Okay, I want to look through this spatial pooler structure. So these are mini columns. This is their like potential pool / receptive field. Each cell receives the same feed-forward input. Input flows through proximal synapses. Yeah, these are proximal connections. Hebbian learning, online learning. It's a good summary. Sort of breaking out what an SDR is as represented in spatial pooler. It is nice pictures. I like it when people make their own pictures. You can tell they have an understanding of things. Non-localist, distributed non-localist resilience. That's an interesting way to put it. Learns to map similar inputs, similar outputs. Similarity can be computed with a dot product. And then the essential algorithm explaining overlap, comparisons, and then inhibition. I don't think I've seen these algorithms. I think these algorithms these aren't coming from our documents, I don't think. So that's interesting too. I mean, of course, there's lots of, this all came from intuition of looking at how neurons were working and trying to figure out what they were doing. So we didn't start with the math. You know, you've got to go find the math that explains the biology. So it's interesting to see people finding the math for it, right? That's cool. And I'm not going to verify whether this is right. I'm not a mathematician, but this looks somewhat familiar. The sets, like I said, I'm not a mathematician, but inhibition. So we're talking about groups of neighborhoods. Okay, motivation. Our research is focused on bioplausibility and emulation of the pathways in the neocortex. I would agree with that. Binding operation is the basis for content addressable memory, which could help facilitate long-term storage and retrieval. Content, I think I've heard about this before, but I'm not enough to define it. This must be his motivation, perhaps. Combine multimodal data without increasing dimensionality. Definitely. HTM is a way to do that for sure. We're going to check out the asymmetric confidence thread. I have some things to look at that may be wrong. Yeah, I'll pop over there. Got 10 more minutes. He's talking about the binding problem. Vector symbolic architectures, vector operations, different implementations of VSAs. I am not familiar with these. Sparse binary distributed representations. I think I remember this. Thanks for the follow, James. Interesting enough that you could stick around for the next one. You know, I have a schedule if you want to look at it, and I try and put events up on my events page. So if you're on Twitch, look down at my schedule, and that's usually right. But there's a link to an events page that I try and keep totally updated. So like, there's an event in 10 minutes where I'm going to be working on a project. I can feel the sarcasm, James. Okay, so this is cool. Binding and unbinding. I'm gonna skip some of this. Maximally sparse SDRs. Use local inhibition, visual polar. Fast retina key point. So this is what I have not. Freak encoding. I've never heard of this before. Fast retina key point. So we're looking at like multimodal data, or no? Difference in Gaussians. I guess it's something I have to look into. Is the fast retina key point? Fast retina key point. Oh boy. Okay, so it's like basically I'm gonna have to read a paper. I'm not gonna read the paper because if it's interesting, if somebody's interested in the fast retina free point and you think it's a valid thing to relate to HTM, which this guy obviously does. But basically, I'm going to ask someone to explain this to me on the forum, if you want to. I mean, because I'm not going to go down the rabbit hole right now because I have to get work done today. So like 9 to noon, I'm going to be working, and this is going to take me down. This could be half an hour. You know, I don't want to do that. You did the scan of the paper. Okay, cool. Cluster analysis, binding experiments. I love seeing this stuff though, even though I don't understand what it's doing. I mean, the ideas behind HTM are going to be behind a lot of things, you know, of understanding more about how, what you can do a lot of stuff with it, I think. So that is very cool. That's great. Really, that is really interesting, for sure.